Write a function whose graph is y is equal to the absolute value of x, but is a shifted to the right 4 units. All right, so let's start with that first one, a, shifted to the right 4 units. So if you want to move this graph along the x-axis 4 units, remember, we basically want to put the function on paper, but leave some space inside the absolute value area to add or subtract something that's going to move the graph 4 units along the x-axis. Remember, you work inside of the function sort of to move it along the x-axis. So in this case, it's going to be the opposite of what you would think. The right side of the x-axis is positive, so we're going to actually make it -4. If we do that, that's going to move the graph actually 4 units to the right. So that's example A accomplished. Let's do part B. For part B, it says we want to shift the function down 4 units. Well, if we start with the original graph they gave us, absolute value of x, to move this down 4 units, we're just going to subtract 4 from the function. So at the end of the function, you just put a -4, it'll move it down 4 units on the y-axis. So remember, when you're moving it on the y-axis, you just add or subtract the amount of units you want to move it to the back of the function. If you're moving on the x-axis, you do the work inside the function itself. So if it's a parabola, you do it inside the squaring piece. If it's a square root function, you do it under the square root. If it's an absolute value, you do it inside the absolute value symbols. All right, let's look at example C. It says reflect the function across the x-axis. So if you want to make it appear as a mirror image across the x-axis, you just put a negative sign out in front of the function itself. So it'll be y is equal to negative absolute value of x. And this will basically make the function open down instead of opening up. All right, let's look at example D then. Vertically stretched by a factor of 4. So all you have to do this is to put a 4 out in front, right? So in other words, it'll be y is equal to 4 times the absolute value of x. And that'll basically accomplish the task of stretching it upwards by a factor of 4. So whenever you want to stretch a function in the vertical direction, you simply put a number out in front. So 4 would stretch it by a factor of 4. If you want to stretch it by a factor of 2, you put a 2 in front. It's very simple. Now let's look at the last case, example E. And this one is a horizontal stretch. So whenever they want you to horizontally stretch a function by some factor, you want to put that inside of the function again. So inside the function attached to x. And the way that's going to work in this case is that we're going to have y is equal to absolute value of x over 4, or 1/4 x. Now, the reason why it has to be a quarter is because we want to stretch it outwards in the horizontal direction. We want to make the function open up wider, right? For every x value we put in there, we don't want it to open up as high on the y-axis, right? So if you put in 4 for x, normally you would have gotten 4 out for y, right? So normally if you have y is equal to the absolute value of x, and you were to enter 4 in for x, you'd get y is equal to the absolute value of 4, and that would give you that y is equal to 4. However, if you have the quarter in there, when you enter it in, you're going to have 1/4 times 4, and you get out only 1 out of the function. So when x is 4, y ends up only being 1 in this instance. So to get to y equals 4, you have to go all the way out to x equals 16, right? Because 1/4 of 16 is 4. So what that's going to do is make it look very spread out. For example, the original, drawing might look something like this for y equals absolute value of x, but with this new piece, it might actually look something like this, right? Very, very drawn out, because you have to get very far out on the x-axis before the y begins to rise substantially. So basically, it kind of spreads it out in the horizontal direction, and that's basically what they're asking you to do.